Good morning, dear students. Today we are going to discuss Chapter 1 Real Number, Exercise 1.3 of 10th class Punjab School Education Board. In this exercise, we are going to discuss what are irrational numbers. As we have studied in our lower classes, we start from natural number, that's a part of whole number, is a part of integer I or z. Integer is a part of rational number, and there is another number which is called irrational. These two are the families of a set of real numbers. So we'll discuss here irrational numbers. Let us start with example 1. We are to show that root 5 is an irrational number. As we know that a rational number is in the form of p by q. Let us suppose this number root 5 is a rational number. As root 5 a rational number, we can write it in the form of p by q, where three conditions applied. P and q are positive integers, belongs to integer, and second condition is most important, that q must not be equal to 0, and our third condition is p and q GCD is 1, that is highest common divisor is 1, greatest common divisor is 1. There is no other number than 1 which is common between p and q. We also can call them co-prime numbers. Now let us solve this. Taking square on both sides, we get root 5 square equals to p square divided by q square. This will become 5 is equal to p square by q square. So 5q square is equal to p square. Here, as we can see, on the left hand side, q square is multiple of 5. That means this term LHS 5q square is divisible by 5. If the left hand side of an equation is divisible by 5, then right hand side, therefore p square is divisible by 5. As we know that, but 5 is prime number, so 5 divides p also. Therefore, there exists a number p such that 5 of r. Therefore, if 5 is dividing p, so p will be a multiple of 5. Let us take it as 5 into r. We repeat the process again by substituting the value of p in equation 1. From equation 1, 5q square is equal to, we'll substitute the value of p 5r in equation 1. We'll take the square of whole, it will become 25r square. After solving, we'll get 5r square. So in this equation, 5r square is divisible by 5r square is divisible by 5. If right hand side is divisible by 5, so left hand side, therefore 5 divides q square, but as we know that 5 is prime, so 5 divides q. So if we conclude these two equations, two statements, 5 divides p and here 5 divides q, that means 5 is common divisor of p and q. But initially we said that p and q, they are only having one as common factor, not any other common factor other than 1. But as we know p and q are co-prime, so we approaches to a contradiction. So our supposition is wrong that root 5 is a rational number. So we conclude that root 5 is an irrational number. Let us revise this very quickly. We are taking root 5 and as a rational number, let us take it as p by q. Taking the square, we get 5q square is equal to p square. But if LHS is divisible by 5, so RHS, if RHS is divisible by 5, p square is divisible by 5, but p is prime, therefore 5 divides p. Similarly, solving the same process, we will get 5 divides q. So we got 5 is dividing both p and q, but we have taken here p and q as co-prime numbers, so we get a contradiction here. Therefore our supposition that root 5 is a rational number was wrong. So root 5 is an irrational number. Let us do another sum. We are to show this 3 plus 2 root 5 is an irrational number. As our previous question, let us assume it again as this is a rational number. So 3 plus 2 root 5 is equal to p upon q, where all those three conditions, p and q belongs to integers, q is not equal to 0, p and q having GCD 1. So we'll shift this, 2 root 5 will become p upon q minus 3, 2 root 5 is equal to p minus 3 q by q, and root 5 is equal to p minus 3q divided by 2q. As p and q are integers, so this becomes a rational number. RHS of above equation is a rational number. So root 5 is also a rational number. But we have proved in our previous question that root 5 is an irrational number. So we So by reversing the steps, we got, therefore 3 plus 2 root 5 is also an irrational number. Let us solve another example, 7 root 5, to prove this as is irrational. Solution. Let this is posed as P by Q, where all the three conditions exist again. So 5 is equal to P upon Q 7, as P and Q are co-primes, so they are forming a fraction. Therefore RHS is a rational number. Therefore LHS is a rational number. But we know that we have proved here root 5 is an irrational number. So again by the reverse order, so therefore we conclude that 7 root 5 is also an irrational number. So with this we have completed our exercise 1.3 of chapter real number 10th class. Thank you.